In the second video, we are exploring the different types of data commonly encountered in reliability engineering. So the first table contains a number of units, 17 units, for which we recorded the exact time to failure. So there are no repairable units that have failed, and once they fail, they're going to be replaced by identical unit at time zero. So this is if we want, the most precise type of data we will analyze, because it does not contain any uncertainty that is included, for example, in the other types of data that we're going to show. So the next table is called rise sensor data, and it is a combination of failed unit that we label with an F and a combination of surviving unit or sensor data that we indicated in green with an S. And what we are indicating for those units, at 19,200 hours, they were perfectly operating, but we don't know exactly when they're going to fail. And that's why they're labeled rise sensor data, because the uncertainty of their time to failure is on the right-hand side of this 19,200. And this is a perfectly common type of data used or encountered in reliability engineering. For example, if we imagine warranty analysis, there will be a number of units that fail and the majority perhaps are still operating. Or in a test, where the test is either failure terminated or time terminated, a number of units fail and a number of units are still surviving. So this is a very common type of data used that we have to face in reliability engineering. Another type of data, again, that contains some uncertainty, is interval data. But this time the uncertainty lays in the interval. So we have a last inspected time when the unit was operational, and we have a time when we identify the failure. So, and this is the type of scenario, say for example, where the failure is only revealed via an inspection. So it's a kind of hidden failure that we are only able to identify via an inspection. The last type of data is left sensor data, which is a special category of interval data, in so much that the last inspection was at time zero. So at time zero, we commissioned the product, was perfectly operating, and then when we analyzed at this time, it was not operating, it failed. So it failed in the interval 0 to the first reading, or whatever the time it was. And so these are the types of data that we encounter in reliability engineering, and it could happen that in some cases we even got multiple different types of data combined on the same analysis. So we need a software to be able to handle this type of complexity, and that's why a software comes so useful in a situation like this. In the next video, we'll be looking at the models used to analyze our data in reliability engineering. So see you in the next video.